Welcome to the Bodhi Academy. My name is Shrutika and today let us study the chapter 9 from 7th standard class, Motion and Time. So today we are going to study about the chapter Motion and Time, which is chapter 9 from 7th standard textbook. So let us first understand the meaning of motion. So motion. An object is said to be okay. So what do you understand by the term motion? So motion. So the term motion means an object is said to be in motion if it changes its position with respect to time. So whenever an object changes its position with respect to a particular time, the object is said to be in motion. So this is the definition of the term motion. For example, a moving car on the road. So a moving car is said to be in motion. So this is an example of motion. So now let us see. So this is the meaning of motion. So we have understood the meaning of motion, that a motion object is said to be in motion whenever it changes its position with respect to time. And in our previous classes we have also studied types of motion. First type of motion was a motion along a straight line. Then the second type of motion was rotation motion or circular motion, and the third was periodic motion. So here we can see some examples, and now let us classify these examples based on the type of motion the example represents. So let us look at the first example. So the first example says okay. So the first type of example says that soldiers in a march past. So soldiers in a march past moves along a straight line. So soldiers does not move like in a circular direction, they move in a straight line. So this type of motion is said to be a motion along a straight line. So the first example is of the first type of motion, that is motion along a straight line. Then bullock cart moving on a straight road. So bullock cart moving on a straight road is also an example of motion along a straight line. The third example, hands of an athlete in a race. So when athletes move, their hands moves from the left to right position. So this type of motion is called as periodic motion. So this is an example of periodic motion. Then pedals of a bicycle in motion. So pedals of bicycle, when the bicycle is in motion, the pedals of the bicycle moves in which motion? It is circular motion. So the pedals of a bicycle will move in circular motion. Then the motion of earth around the sun. So the earth moves around the sun in a circular direction. So this example is of circular motion. Then motion of a swing. So a swing also moves in a left to right direction. So it is example of a periodic motion. Motion of a pendulum. So we have seen pendulums in the wall clocks. So this pendulum also moves from left to right side, and this is also an example of periodic motion. So in this exercise we have seen that some examples, and those examples we have classified according to the motion that they represent. So for example, over here, soldiers in a march past moves along a straight line. So they represent the first type of motion, that is motion along a straight line. Then bullock carts moving on a straight road. So bullock carts, when they move on a straight road, they represent motion along the straight line. Then hands of an athlete in a race. When the athlete moves in a race, when they run, their hand moves from right to left direction. So this type of motion is called as periodic motion. Then pedal of a bicycle in motion. So bicycle, basically it moves in circular direction, so it represents a circular motion. Then motion of earth around the sun. So when the earth moves or rotates around the sun, it takes circles. So they take rotations around the sun. So it represents a circular motion. Then motion of a swing. So whenever we sit on swing and then we swing, we go from left to right direction. We go forward and then again we come backward. So when we go forward and again come backward, that is from left to right direction, it is representing a periodic motion. Also, a pendulum in motion represents periodic motion. So this was about the exercise 9.1, wherein we have classified different examples of motion according to the type of motion they represent. So now let us see the second concept, that is speed. So here we can see so let us take a small example, that is figure 9.1 and figure 9.2. So in both the figures, what we can see is the cars are moving on a straight road. So the cars are moving, so they are in motion. So if we see in both the this thing, in the second picture we can see that some cars have moved forward, or they have gone beyond the position which they represented in the first picture. So why is this happening? See over here, we can see the first here, the green car, it was here initially, but after some time I can say that it has gone forward, or it has moved fast and it has changed its position. So I can say that it has increased its speed, hence it has covered some more distance in the second picture. So first, initially it was here and it has moved here. Again, the red car over here, we can see that it was over here initially it was over here, and in the picture we can see that it is still there. So I can say that it has not covered that much distance, so that it is slow. Again, if I see here, I could have I was able to see a grey car, but in the second picture the grey car is not there. So I can say that it has moved fast, so it has covered a greater distance, hence it is not visible in the second picture. So like this, from comparing both the pictures, I can say that some car have moved fast and some car are still at that position because they are moving very slow. So how can we determine, or how can we how can we determine the movement of the cars? That is, how can we say that some cars have moved fast, or some cars are still there, they have not covered certain distance? So this can be determined using by calculating their speed. So now let us see the concept of speed. So speed is basically the distance covered by an object in a unit time. So speed of an object is basically the distance covered by an object in a unit time, is called the speed of the object. So it is basically the distance which is covered in a particular time will give us the speed of the object. And depending on the speed, we can say that the object has moved fast or object has moved slow. If the speed is more, the object moves fast, hence it is covering a greater distance in a smaller time, and if it is slow, then it is covering a smaller distance in greater time. So this is how we can determine the speed of an object. So speed of an object can be determined using a formula. So speed, so we can say that speed is equal to distance upon time. So if I have an object A moving to an object B, so this is the distance. Okay, so object is covering a distance AB. Okay, to reach from A to B, it is covering a certain distance in a certain amount of time. So if we know the distance covered by an object and the time taken to cover that object, we can find the speed of any object. So speed of any object is determined by the time and the distance traveled. So speed is represented as the following formula, that is distance upon time. So we shall use the following the following formula, that is speed equals to total distance covered upon the total time taken. So this formula will give us the speed of any object if we know the distance and the time taken to cover that distance. And depending on the speed, we can classify the objects as they are moving fast or slow. So in our today's class, we have learned about the motion, the types of motion. We have classified different types of motion depending on the different examples. Depending on the type of motion, we have classified them, and then we have seen the concept of speed and the formula to calculate speed. Thank you for watching today's video. Please don't forget to like, comment, share and subscribe.